Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Free radical stability follows the order based on resonance and hyperconjugation. Moving on to the next step. Evaluate option A. Bromine is indeed more selective and less reactive in free radical halogenation due to the higher activation energy required and a more endothermic hydrogen abstraction step. This is a correct statement. Moving on to the next step. Evaluate option B. Chlorine is less selective and more reactive in free radical halogenation because it reacts exothermically with lower activation energy, attacking primary, secondary, and tertiary CH bonds with less discrimination. This is a correct statement. And for the final step, evaluate option C. Benzyl free radical, PHCH2, is stabilized by resonance delocalization into the aromatic ring, making it more stable than a simple secondary, 2 degrees, free radical which is only stabilized by hyperconjugation. This is a correct statement. Evaluate option D. The vinyl free radical, CH2 is equal to CH, has the radical on an sp2 carbon, which holds electrons more tightly and provides no resonance stabilization to the radical. The allyl free radical, CH2 is equal to CH, CH2, is stabilized by resonance delocalization over 3 carbons to resonance structures. Therefore, allyl free radical is more stable than vinyl free radical, not less. Option D states the opposite, that vinyl free radical is more stable than allyl free radical, which is incorrect. Why other options fail? Options A, B, and C are all factually correct statements about halogen selectivity, reactivity, and free radical stability, so they cannot be the incorrect statement. Therefore, the correct answer is D. Therefore, the correct answer is option D.